Hi folks, this is Adam here, going to give you a rundown of the new features in Cancha 2.6 in September 2025. It's available now to be downloaded from the website for all subscribers. Jumping straight in, going to go through these new features quite quickly, and for the more important features, I will do separate videos. Okay, so just jumping through them, just to be aware, we do have now short names in Cancha. So in the past, for example, if we had like lithology, which we had the word like limestone, it's quite long, more than 6 characters, and it would crowd out some of the graphics, and it was difficult to get block plots and things like that to work, labels to work in the space available. So it generates abbreviations. Just right click and go to legend on the feature. And then you've got, you can see here that the limestone was automatically abbreviated to limestone. So we've got an algorithm there that hopefully does a reasonable job. If it's not doing a reasonable job, then the trick is to go in and edit it yourself and then have the abbreviation that you would prefer. Okay, so that's short names, and it just makes having graphs and things like that a lot more easier. So there's more consistent sample focus. You know, when you click on a sample here in the sample list, for example, it'll be more consistent throughout Cancha, you know, through logs and 3D. If you're working on separate screen views and stuff like that, clicking on one thing in one view and having it consistently available in the other views is going to work better now. And also, in order to take images, to say I wanted to take an image here, there's only 2 buttons now. There's the 3-view button and just the scene copy to clipboard button, and that's the one that's Control-C as well on your keyboard. So the first one gives you the front, top, and side views orthogonally projected, and then the second one just gives you a nice clear copy of the scene that you currently have on the screen. Better quality and better sizing than previous for pasting into things like Word and whatnot, PowerPoint. You'll notice there's a third button here now, which is new as well. So we click on that. This is block model to shells. So we've always had shell to block model, but now you can go from the block model to the shell. So let's just have a look at this one we've got right now. We just come out of that and I already did it, so it's kind of crowding out. Let's just turn off shells for the time being. So right now we've got this block model, and it's already been trimmed. Obviously, it's got some. It's not a square, but we've got this block model information. Maybe we want to take off everything that's to do with fresh and transition and others, and all we want to have is the oxides on there, right? So you can see now we've only got the oxide blocks that are showing. And if I hit this button here, what it's going to do is going to create a shell according to that. So now if we come into shells, you'll notice I've got 2 new ones, and one of them is I have to turn off the block model to see it. So I hit the button twice, right? One of them was with to turn shells on here, and we'll turn the final pit off. So one of them was without sulfides and one of them was with. So that's obviously the green one is the first one I did. So this is the one that's only oxides. Okay, so that's now available because it could be useful if you make it sort of ghostly. Then that can give you a really nice view of where your samples and drilling are compared to just the oxide. So you could do the same, for example, if you had you know, certain grade reductions or things like that. So if you've got a filter turned on, if you've got things that are filtered, and then you can capture the block model shape as a shell, and then that can be useful. More to do with shells. So that's one thing we can do with the shell. Another thing we can do is we've got the final pit here. And as you guys would have, if you're current users, you'd know very well that you can do the intersection of the shell with the block model by coming to features, and then this button here, which is shell to block model, we'll choose the final pit there and hit apply. And what it's going to do is project that shell onto the block model. And if we just load that up, we can see in the block model features, we've got the final pit. Click on that, and now whatever is outside of the pit is green, whatever is inside the pit is orange. So that's what it's always done. The new thing is final pit distance. So this is the distance to every block for each for every block, the closest distance to the shell for each one. So if we do, for example, a section, and I'll just turn off the drilling and the samples just so we can see a bit clearer. You can see here that I'll turn on a divergent color scheme, which is the easiest one, because you'll notice that there's two ranges. There's negative and positive. So negative is on one side of the shell. So this gray line here is the shell. So blue is the negative on one side of the shell, and red is positive on the other side of the shell. And as you can see, the values go up the further away you get from the shell. So that could be useful for knowing the distance from an oxidation or redox boundary, or from a fault or some other structure. That could be useful for geometallurgy. So that's that new feature there for shell to block model distances. The next thing to talk about would be in analysis. So in analysis, you know, here we've got a plot from drilling of iron versus copper. We can turn on the heat map, and the heat map is a bit better quality now. Before it was a bit pixelated and whatnot. Now it looks quite a bit better, better for the reports. And also if we hit sample coverage, this is a new thing that covers the heat map, where we can see where the metallurgical samples are in respect, in this case, to the drilling for copper and iron. So it's just basically the copper and iron grades for the met samples plotted over the top of the heat map for the drilling. So you can see how representative your samples were in that respect by this kind of graph. Okay. Something else that we've got is the logarithmic x and y axis. You just click down on that, and then you've got log, yeah, or log. So that's useful for some kinds of data distributions. We've also got in box plots, you can have multi-dimensional, so you can have drilling, block model, and samples all in box plots without cancelling each other out. Before, they all had to come from the same dimension. Now we've got it sorted. You can have the multi-dimensions all on one graph, which is super helpful. So big feature here is we've got this new one, which is, you'll notice here in targets, there's actually 3 modes of targets now. There's the classic targets, there's the domain tree, and the principal component analysis, or PCA. So if we do PCA of drilling, and let's just say we use the assay table, so we'll choose that one. So we selected the assay table in order to do principal component analysis. I'll do a full video on this one for sure. I'll just hit run. Basically, I'll pause the video because it's going to take a minute. So it starts to flicker after a minute, and don't worry, it's not crashing. It's just creating a whole bunch of graphs. PCA is something that you take a bit of time to learn about because it's not super intuitive. But basically what it's doing is taking all that information, looking for clusters, and then it uses 3 different kinds of clustering in order to come up with a result. So here we're offering k-means, Ward, and GMM. You can see GMM creates a whole bunch of different clusters, and so it's sort of not great for geomet, I think. Ward and k-means seem to be the better ones, and you can see that they shade different areas. These graphs here are non-dimensional. Don't try to understand them as a human because there's loads of different dimensions all mixed in there. But basically, it's a sort of visual indication about how close each of these samples are next to each other from the drilling database. And it's really subjective as to what you want to choose as your classification system. In order to help you, we've given each one of the clusters a name based on the things that are having the most influence on each cluster. And then after that, you can go down here and you can see for each one of the clusters, for each one of these colors, you can see for arsenic, gold, cadmium, these are the components that were, these were the things that went into the parameters that were most important in classifying the clusters. And you can see that one domain might have very low moly, for example, but it might have very high chrome in the same one. Okay, as we come down to sulfur, you can see you got 2 domains that have got low sulfur, and one has high sulfur, and one is between the 2, right? So what you need to do is try to look at this with a geologist and a metallurgist together, and try to see what geological events, whether it's mineralization, alteration, rock types, stuff like this, what has caused these to be different. But because principal component analysis is an unsupervised learning technique, it means that it's not necessarily going to line up to anything that you're trying to predict in geometallurgy, which is why I think PCAs have pretty limited use, generally speaking. But give it a crack, and if you can get it to work, what you need to do in order to make it use for it after this, further down you've got also some drill holes. So you can see how down the drill hole each of these different elements has been clustered, as far as values go. So, you've got, high gold, and then lower down the standard deviation down the hole. Anyway, try to get your head around it. Once you've chosen which one you want, let's just go for the time being with k-means. So if you want to make use of it, you just hit k-means and then apply. And then back in, for example, logs, we're going to have this new feature, which is under derived, and it's a cluster of this one, right? So we can pull this new clustered view into here, and you can see here that it's classified this area of high sulfur as being this one, and that's the high sulfur and high moly, whereas the high sulfur and high vanadium, or pretty low sulfur and high vanadium is this other one. So anyway, you have to get your head around it, go through a bunch of holes, trying to work out what they line up with. And then in 3D, you can look at them. So let's just turn off some stuff and look at the drilling, and then we load up that one there, and we can see here, turn off the met samples. So now we can see here those clusters in 3 dimensions throughout the deposit. If you find this useful, put a comment in the video, or email me. Love to hear about it. We haven't found PCA to be super useful in Geomet. Tends to line up with the main lithologies and things, but give it a crack. Maybe it's good. Maybe you'll find a way to make good use out of it. Another one in here in targets is this domain tree. So in the domain tree, this is a supervised learning. So we have to tell it what we want to predict. So let's say, for example, we want to predict, let's say A by B. Okay. So we put it in there and say, let's just give it, again, all the assays. Let's give it the assays, but let's also give it alteration, and we'll give it lithology too. So I can use any of these features in order to try to predict the domains. So we'll just go ahead and run that. So I edited the video. That took about a minute, and you can see now we've got these domain trees for A by B here on the left. The 000 are the ones with all the data, and the 100s are the ones that have had the outliers removed. And we can see here, this one here, for example, using alteration, sulfur and arsenic has an R-squared of 0.85, which seems to be quite high. Certainly higher than the others, I think. So that's the best one here. The 0.85 is the best correlation coefficient. If we look at it, the first thing it did, so we click on set 0. This is all the data, the 20 samples. You can see that it's got a variance of 1800, which is a huge number. Obviously, I know A by B is like non-additive, so I guess it's not the best one to look at numerical methods, but you can see that the average here is 60, and that argillic goes one way. It has what is less competent than the silicified and the propylitic alterations, which we've got 46 A by B. So 93 versus 46. This is a more competent one here. And here we have 6 samples, and here we have 14. So if we click on it here, you'll notice that it gives us this graph with all the argillic to the left of this red dotted line, and all the propylitic and silicified on the right hand side. And sure enough, you can see that there does seems to be something there. It's not perfect, but it certainly does look like the argillic has got a bunch of less competent samples, whereas the other alterations don't have that. And then we can go to the next level. So we click here again on set 4. This is separated by arsenic. And you can see here at this arsenic cutoff at 20.59 grams per ton. To the left, we've got the less competent material, and to the right, we've got more competent material. Okay, so you can sort of see, okay, that might be interesting. And then further down again, another one with more arsenic again. Here it's by sulfur. So, low sulfur's got high competency, and high sulfur has got low competency. That's actually a pretty cool one. I like that. Looks like there's something going on. So again, just like all the other things in Cancha, this is just numerical methods. It's just artificial intelligence. It doesn't really understand geodeposit and the geology and the metallurgy. So, but it does generate a whole bunch of ideas. So what you can do is you can click on this and go through, and you can look at what effect the iron might have, and what effect the sulfur might have on the high iron and the high iron and low iron. And you can look to see this, and maybe you're going to find some domains that you might find to be super useful. Okay, so domain tree, it's a great addition, and this is something that we do use a lot of. So going back to the samples, what we have is this new thing called the sample report. And let me just clear this out for a second, and then I'll show you what it is. If we click on a sample here in the sample list, so I'll just click on sample 4 randomly. The first thing it does at the top here is give us, you see this? It gives us the sample location in eastern, looking north, looking east, and looking top view. And then what we've also got here is we've got the things that this sample for. How is this unusual? Because oftentimes you might be looking at a sample and say, oh, this is very competent rock, or this has got a very low recovery or a very high reagent consumption. I wonder why this sample is different to all the other samples. So what you do is you click on the sample report and click on the sample, and it'll automatically find the reasons that it's unusual. So in this case here, it's unusual that it's got quite a high gold grade. It's got a very low sulfur grade compared to, scandium grade compared to the rest of the samples. And it's in the transition. There's only 3 out of the 40 samples, or whatever, 50 samples that are in the transition. That makes it very unusual. Okay. Now you might say, well, I'm really not interested in scandium. Why don't we have, copper or something more useful, or silver grades? So, well, you can do that. So what you do is here in the characteristics of the met samples, you can pull in silver, gold. Let's put, copper. Right. So we can add those there, and we can also pull in things like, for example, the lithology. Right. So we can have numeric and categorical stuff, which will always be there. Whenever we click on a sample, it'll always give us that as a minimum, and it'll also give us whatever else it finds as being why the sample's an outlier. So here we can see here that the rest of the samples are here, and this sample's way up here. So it's a very high grade gold sample. It's also got high grade silver, and it's limestone and stuff like that. So you can see where the sample's from. So this is what makes this such a great detective tool, because if you're trying to find the reason why a sample is unusual, then you can come here to the sample report, and it'll find straight away the reason that the sample is unusual. Okay, and also if you just want to have routine data and an easy dashboard, you can have that as well. So back in the targets again, there is one change that we do have here in the normal targets thing. So we want to do, for example, gold recovery, and just go ahead and run that. Previously, as you know, we used to have like the domains that would come up on the left there, and all it would be was a box plot. And so now we've added some more information there to help people understand it better. So now, for example, we bring up these oxide domains from the block model. You can see this usual box plot, showing the difference in recovery for each of them there. But you've also got this table with the frequency and all the statistics and the total number. So that's a lot easier sort of dashboard to look at for the gold recovery by oxide domains. But then down the bottom here, we've got these 2 new mosaic where you can see that you've got the domaining system along the columns, and then you've got the target by the rows. So you can see that most of the samples have got higher recovery, and there's only one. This is the frequency, right? This top one is the frequency. So you've only got like one sample and a whole bunch of these different ones. So when you're looking at this difference here, you can say, oh, this has got high recovery and this has got low recovery. Yeah, but this has got 60% of the samples, and this has got only just one in each, right? So it's kind of nice to be able to, the box plots kind of don't show that, but now using these two mosaic plots, you can start to get a feel for where your important domains might be. Okay, so that's an important addition there. Final thing would be sample selection. So, there's one more other thing. If you come here to this one here, which we call the sample classification, say, for example, we wanted to know about, let's just keep going with the typical alteration and lithology. What we get here is a list for each one of these domains for the different alterations and the different rock types for the intersection between the two. We get a list of the samples in each intersection. So that's kind of a specific use, but some people might find that to be super useful for sure. But the one over here, we come to sample selection. There has been a change here, and this change is important. It is in drill hole grouping. So drill hole groups is this new thing. I've got this one that's already been done, 2025 drilling, but I'll just do another one just to show you. So like say for example, I was to choose these first 5, and we want to call, maybe we're going to call that diamond drill holes or something like that. Maybe the rest are all not diamond drill holes, so we're just going to call those diamond drill holes. So when we're going to choose a new phase, so we're going to choose, for example, phase 5 samples. Maybe we want to get 15 samples of 12 meters long each, but we want to. This is another new thing. You can avoid existing sample intervals. So when you click on this, it's no longer going to be taking new samples on top of existing samples, which is obviously should have been done a long time ago, but it's there now. It's working. You choose a focus case. So let's just say in pit. And the sampling frame is exactly what we just did with the drill grouping. So you no longer have to go down through the list of drill holes every time choosing which holes you want to choose the samples from. You just come here and say, I want to choose them from the diamond drill holes. And I've got my principal features list, hit apply, and that's going to choose phase 5 samples for us. So there we have it. We've got our 15 samples, and we've got the plots for the representativity. But if we come here in logs and we look at the samples for phase 5, you'll notice that they no longer coincide with any previous sampling. And if we want to come back and do another sample selection along the same lines, we don't have to go down and collect all these, like do the checkbox on all the samples again on the drilling that we want to use for the sampling frame. We just have to choose the group of drilling. At the same time, if we want to do a 3D image of those groups, then we can just click on the name there, and then as you can see, we can say, okay, give it a caption and say this is the drilling there for 2025, or that these are the diamond drill hole. So that's good for the report. Okay, so clicking on those. That is a quick walkthrough Cancha 2.6 improvements. So get in there, try it out. Hope you enjoy it, and if you come across any bugs or you have any questions or you're not sure about how any of this works, just get in contact. I'll be happy to give you a hand.